Up next, we have Marianne Blotti. She's a software engineer who's worked on safely sharing humanitarian data for the United Nations and ran modernization teams as a consultant in New York before joining the United States Digital Service. As a part of the USDS, she spent 3.5 years working on some of the oldest and most complicated computer systems in the world. She's since returned to the private sector, working for Auth0 and Rebellion Defense, specializing in system safety with technical debt-heavy systems. Marianne's here to share her talk, This Code May Kill People, Refactoring Ethics into Software Design.
Hi, everybody. My name is Marianne Bellotti. I work for a company called Rebellion Defense, and I'm here to talk to you about factoring ethics into software design. So, to start off with, I've been a software engineer for about 15 years. I've taken to referring to myself as a relapsed anthropologist, since all of my formal education is actually in anthropology and organizational design. And lately, over the last 5 years of my career, I've been bringing more and more of those skill sets to how I deal with engineering teams and computers rather than just strictly math, science, STEM skills. Over my career, I've done lots of government work, including 3.5 years at United States Digital Service. Lately, I've been working core services at a company called Rebellion Defense. Now, as the name Rebellion Defense probably implies, I work for the defense and national security industry. And some of this, while most of this talk doesn't actually deal specifically with the military, it deals with the process of building software. Part of introducing those concepts include getting personal about my story, which means that we're going to discuss the U.S. military environment to a certain extent. So I want to give you a bit of a content warning before we start off. But I also want to clarify that doesn't mean that we're going to be talking about war in graphic detail. So there's not going to be any graphic content, and I'm going to avoid using military language as much as possible. Generally, when I talk about these issues, when I start to have this conversation with people, one of the things that they will say is like, well, if you care about ethical and safe software, isn't it better not to work with the military at all? Like, it seems like that's a difficult place to really advance these causes. And what is interesting to me about that is that it reflects a sort of general isolationist attitude in technology about the military space versus the civilian space. That very few people argue that we shouldn't have a military, or we shouldn't have a defense or sector, or we shouldn't have infrastructure for national security. They just don't want to be involved in it, and they don't want to touch it. They want to stay in the civilian space and create a very clear separation between these two spaces. The problem and the risk with doing that is that creates bubbles in which very different cultures and potentially very different values exist within the bubbles. And that's one of the problems with military language, is that within the military environment, a lot of the terms that you'll hear thrown around when describing technology projects mean completely different things than people external to those environments interpret them to mean. And this creates a lot of problems when you think about, in America at least, we want our military to be overseen by civilian forces, and we want them to be grounded by rule of law. Those are our values. We want them to reflect democratic norms. And this becomes very, very difficult to do when there isn't a clear channel of communication and collaboration between the civilian side of things and the military side of things, when we isolate ourselves from each other. And so at Rebellion Defense, one of the things we say is that national security is everyone's responsibility, and that we want to create a channel of collaboration between civilian side and the military in order to ensure best outcomes for everybody. So the thing that's important to know about my story is that I tried to do this work in the private sector, and I couldn't really get much headway with it. Because the private sector didn't take software safety seriously, but the defense sector absolutely did. And so like in the tech sector, we have this attitude of like move fast and break things that is so fundamental to the culture of Silicon Valley and the wider tech community as a whole, which sounds great. And certainly when you think about it in terms of the agile software development, it makes a lot of sense. But when you start to consider that these are the things that are potentially getting broken by our software, it has a wide variety. It has a different context completely, right? Like marginalized communities, vulnerable people, democratic institutions. We can all think of software that has been built in the last 5 years or so that has done damage to these communities of people and these things that we hold dear. And so moving fast and breaking things is a completely different meaning when you start thinking about it in those sense. Maybe a couple months ago, I was watching the New York Times serial, The Weekly, that's on Hulu, and they were doing this episode on deep fakes in which they profiled this company, Dessa. And one of the engineers there, the journalist that was interviewing him was really pressing him on like the impact of actually being successful in what he was trying to do, of creating a perfect deep fake. And he said, he had this quote, and it just struck me right away, and it's sort of stuck with me since. He said, that's the thing about humans, right? We only react when people have suffered from something. Problems are going to happen out of this, and we're going to build something, and then we're going to build something to fix it after people have suffered. And it struck me, this comment that he made, because it was really indicative of the attitudes that I was experiencing technology at the time. Tech had this attitude of like, well, let's make money now and we'll fix it when enough people suffer. We'll worry about safety after we've made all the money. And so one of the reasons why this is that a lot of private sector companies kind of see their products as toys and have real trouble imagining the consequences of what they're building. Engineers also skew younger in the private sector and have limited experience and therefore limited maturity. And the defense industry, human suffering is not hypothetical. When I came into the defense industry, what I realized is that I was having these conversations with people that had actually made these decisions that had these kind of life or death consequences for both their people and other people, civilians in other countries, so on and so forth. So for them, it really, this idea of like software should be safe and we should explore the consequences of how it's built on safety really resonated very deeply for them. And they took it seriously in a way that I had not been exposed to before. So, one of the reasons why the opportunities in this space are so compelling and so interesting to me is that the business world frequently copies from leadership in the defense sector. And the defense market itself is a huge, huge market where like literally billions of dollars are traded all the time. And ultimately people copy what seems to be making other people a lot of money. So the idea that I could develop these concepts and approaches and this process in a space where it was supported and encouraged and seen as a good thing, and then if we were very successful in doing what we're doing, that might spread back into the private sector, that people would copy these things, was a really, really attractive idea to me, that we could potentially have an inflection point where our methods are copied just far and wide outside of the defense industry in and of itself. So the essential question that I'm interested in exploring as a software engineer is, can we change the software development process to help make software itself safer? And so let's go back to the isolationist approach. Generally, when people come into the defense sector from the private sector and they want to kind of focus on more responsible software, they kind of gravitate to this idea of, well, we'll only build things that have defensive applications, no weapons. We won't touch the weaponry at all. And in the beginning, this seems quite sensible because the military, well, the government as a whole, but the military specifically, is dealing with a state that we like to refer to as technology poverty. People who've never been exposed to defense tend to assume that what they see in movies and TV is an accurate reflection of what military technology is like. And what has always struck me as ironic about that is that if you talk to software engineers about how Hollywood depicts like their life and their careers. They're just full of examples of like hilarious mistakes with technology and how technology works. And yet we trust Hollywood to get the military right. Well, the reality of it is that the basic technology that you interact with in the private sector at even a mid-sized company is completely absent in the defense sector. They don't have a lot of the tooling that we have in the private sector. They don't have a lot of the capabilities that we have in the private sector. They are working in some cases on spreadsheets, in other cases on completely manual paper processes. But it might seem like there's a lot of low-hanging fruit in this like purely defensive area. But part of the problem with the offensive versus defensive dichotomy is that really often the difference between offensive and defensive is only really determined by who's on what side of the technology. I have a colleague who put it really succinctly in a way I really liked. He said that when he was in the service, there was all sorts of chatter about military aid and whether this missile system was offensive or this missile system was defensive. And he said the only real difference between a missile system and offensive defensive is who we're pointing it at. If it's pointing at us, it's an offensive system. If it's pointing at our enemies, it's a defensive system. That's the only difference. And so that made the whole conversation extremely difficult for them to have. It almost seemed pointless. And so the other problem with this dichotomy of offensive and defensive is that the reality of it is that any technology that makes the military more efficient can lead to more injury and unnecessary death if the fundamental decision-making process isn't itself safe. So you don't necessarily get very far just kind of focusing on defensive technology only. Instead, one of the ways that we decided that we wanted to think about this at Rebellion was this idea of escalation versus de-escalation. We didn't want to worry too much about whether we're touching the offensive side of the military. We wanted to acknowledge that no one wants the military to act too early or unnecessarily, that people want everything to be appropriate and effective and right-sized. And so what's important to understand about de-escalation is that de-escalation doesn't mean that there isn't a conflict. It doesn't mean that you avoid conflict or that you eliminate conflict, but it means that you give the group of people who need to make a decision more time and more information with which to check to make sure that the way they're responding is in fact the right way to respond. So current military technology kind of leans towards escalating things in some interesting ways. And so there are three basic problems with, I would say all technology, but technology in this space in particular. First of all, the brand that the military uses colors and design elements that we know make people more aggressive, make them more prone to jump to conclusions, make them more prone to get excited. Machine learning and AI companies frequently mislead about the accuracy of their products or how the conclusions are drawn from them. And then the last point is that there are fundamental misunderstandings about automation itself. So let's go through these pretty quickly. So military brands, generally speaking, the software that's designed for the military will tend to lean on the colors towards the right side of the spectrum, which are all warm, active colors, and less on the colors on the left side and less on the colors on the right side, which are cool, kind of more calming colors. And what's interesting about this is that if you go into other industries that have a really strong developed discipline around safety, you'll see that they are very careful and strict about how you are interrupting people and how you are triggering those kind of excitement pathways in the brain. So for example, this diagram is from the aviation industry, and it kind of lays out their policies around alerting as an industry. So the conditions in which they will allow a strong interrupt in the cockpit mean that if the pilot doesn't do something immediately, the plane is going to fall out of the sky, and that is the standard. And everything else has weaker and weaker and weaker interrupts, and they're very specific in their guidelines around what it means in terms of colors you can use, what it means in terms of like how that alert manifests, and in order to minimize both distraction but also ensure clear decision making from the pilots. So you're going to hear me talk about this idea of system safety or safety science. And it's an academic discipline that's grounded in our lessons learned from aviation, nuclear energy, medicine, etc. One of the fundamental concepts of it is this idea of empowering the operator, that a person on the ground needs as much discretion as possible. And when it comes to computer science, we don't really have a sense of safety science. We haven't really integrated those concepts into our process in a real way just yet. But for the purposes of what I do in our conversation here, it really leans heavily on this idea of human-computer interaction. Like, the computer doesn't replace anything, it supports. And so, let's get to the second point, like AI black boxes. The main problem with AI machine learning companies is that what incentivizes them to produce accurate AI ML products are forces that can be satisfied by just the perception of accuracy. And so this is not exclusive to AI. We see the same sort of problem with diversity, with greenwashing, organic, and we also see it with safety, where the perception of being safe, the perception of being organic or environmentally friendly gives you the same benefit as actually being that way. And so when AI machine learning companies are not honest about like what exactly their products are doing, how they reach the conclusion, the confidence level of certain types of analysis, it creates a situation where the user is going to make a lot of errors based on that analysis, and that becomes very problematic. And so the last thing is this idea of the fundamental misunderstandings that people have about automation. You have likely heard people say this a lot, and we'll continue to hear people say this a lot, that automation will replace jobs, that it's going to remove jobs. But the reality is that automation doesn't actually do that. It redistributes things. So automation redistributes human labor. While it may eliminate a job by automating a process, it's also creating jobs because you need people to write that automation and then maintain it over time. The problem from the political point of view is that the people who lose their jobs to automation are generally not the same people who get the new jobs as a result of the automation. But for the purpose of this conversation, what we need to really understand is that this redistribution affects our ability to adapt, and it changes what we do. So automation redistributes human thought process, and in doing so, it also redistributes where the decisions are being made within a process. Empowerment is a really important concept in this because it's like we need to give the human operator freedom to make decisions. And in order to de-escalate, we've already said that we need to create more time and space for thought. A lot of things, something that you'll hear ethical AI people say all the time is keep human in the loop. Humans in the loop is the equivalent of empower the operator. It basically means like computers should not be making decisions. People should be making decisions. But the problem with that is, how do we know if a computer is making a decision or not? Well, all right, let's suppose we have an object detection algorithm. And this object detection algorithm takes this picture of an adorable kitten in a wheelchair and identifies it as a cat. Is that a decision? On the surface of it, it doesn't seem like it, right? It's object detection. It has detected an object and correctly labeled it. But what if this object detection algorithm sees this picture of an adorable kitten in a wheelchair and gets confused by the wheelchair and goes, no, this is a pair of scissors. It's not a cat. Is that a decision, right? Well, it really depends on the context, right? If our process is such that we are doing object detection on this in a way where a human can sort of fact check the algorithm, and so that those mistakes are very easily identified, then it's probably not a decision. However, if we're doing it over the course of millions of photos, to the point that humans are never going to look at these things, and that maybe these determinations actually have real impact when they're wrong, you would look at that as like the computer essentially making a decision for the human. And so human supervision may not scale, which what makes keeping humans in the loop as a directive for ethical AI well-intended but somewhat difficult to implement. So let's go back to this idea of examining the distribution of human thought. Some of you may be familiar with this concept if you have read the book Thinking Fast and Slow. I call it type 1, type 2 thinking in my writing in this talk. It's also called system 1, system 2 thinking. The idea behind it is that we have different speeds and intensity of thinking. Type 1 is very pattern matching based. It's called fast thinking. It's like versus like. Whereas type 2 is more calculation, analysis, slow thinking, more resource intensive. And what we think happens, the combination of these two thinking, is that the human brain generally has this constant stream of type 1 thinking, and then it uses type 2 thinking strategically in random intervals to error check the type 1 thinking. And what's interesting about this is that computers and humans actually have complementary relationships with type 1 and type 2 thinking. So this cartoon is from XKCD, and it sort of illustrates this concept quite nicely. Something called the Moravec's paradox, which is basically from the very early days of AI, we have realized that things that were really easy for humans to do are actually really hard and resource intensive for computers to do, but calculations that are really hard for humans to do are actually really easy for a computer to do. So in this comic, there are two tasks that we're trying to do. We're trying to check whether a given picture is taken in a national park, and then check whether it's a photo of a bird. And the photo of the bird part is really hard for the computer to do, and the geolocation part, the national park part, is really easy, but that's the exact opposite of the human's relationship with these two tasks. And so where a lot of our thinking around AI and machine learning kind of fails is that we assume that what we want to do to make a process better with this type of automation is to simply use the computer to replace all the type 1 thinking. But the problem with that is that it kind of leaves the type 2 thinking homeless. It means that it's got no place to plug in because the human is no longer doing the type 1 thinking, the computer is. And so a lot of people sort of default to this, well, that's okay because computers are more accurate than people, so the computer doesn't need the type 2 error checking. And that's not really true. Computers are superior at pattern matching when you have given them a clearly defined known pattern. But computers are really bad at identifying the patterns themselves. And the computer doesn't know the significance of the pattern. And so as a result, when we replace human type 1 thinking with computer type 1 thinking and remove all the error checking that type 2 brings to the table, we get biases, we get overfitting, and we have the inability to adapt to changing circumstances, all of which are things that lead to unsafe outcomes with software products. And so we have to sort of think about how we reason about problems. If we are thinking about problems in terms of replacement, meaning that we keep the process the same way, the way it is, and we just use the AI to do the human bits in order to make the process faster, we're going to remove our error checking, and we also remove an element of our resilience because we can't adapt on the fly. And then because we remove those two things, we become more vulnerable to cascading failures and bias. And it also reinforces existing structures, even if they are no longer relevant, which is broadly a bad thing. So this idea of thinking in replacements is appealing because when people talk about process, they tend to think of process in the following manner. They tend to think of process as being this nice, perfectly curated, orderly, step-by-step thing, where there's step 1 and there's step 2, step 3, step 4. And if they correctly identify that step 2 and step 3 can be handled by a computer, then their natural assumption about improving this system and solving this problem is to go from step 1 to some sort of computer generated step 2, step 3 to step 4. And that's how they improve the process. But the reality of processes is that they very rarely look that clean. They tend to look a little bit more like this, where you have a step 1, you have a step in between step 1 and step 2 that's undocumented but is necessary in order to get to step 2. You have, at the end of step 3, you have a condition that is sometimes relevant and sometimes not relevant, that if it happens to come up, you have an inconsistency where you can't even get to step 4. These are how processes look in reality. And so what happens generally with technology is that it tends to grow to fit the shape of all sorts of things in its environment, physical restrictions, policy restrictions, the structure of the organization. Technology can and does typically become root bound, where we build on top of what was built before, which is in itself built based on a bunch of assumptions and environmental variables that may have since changed. And so as a result, we get a system like this where we're parsing XML in order to put it in a database, in order to have a middleware like feed into the API, when probably we could have the API just serve the XML itself if we built it today. And so I tend to push back really heavily from this attitude of let's take the existing process and just add computers and that will automatically make it better, because very rarely is that in fact the case. So there is a word within safety science for this concept of the variation in a real process. It's called drift. And drift is divergence from a specific formal process. It can look like steps being removed. It can look like steps being added infrequently or intermittently. And the important thing to understand about drift is that all processes have some form of drift. There is no process that 100% of the time looks perfectly like whatever the written down version of it is. And so what causes drift? Well, there are three main causes. The first is that the process is blocked and it actually can't be done the way it's supposed to be done. The second is that the process includes a level of variance that is not accurately reflected in whatever the formal written down version of the process is. And then the third cause of drift is that the environment has changed in a way that makes the process itself unsafe, and so we have to adapt on the fly. So in this example of this process, these two orange areas are where our drift is, where we have the adaptation that makes it possible for us to get to step 1 to step 2. That's a drift. And when we have the inconsistency forming due to a random factor, that's also a drift. And so when we think about problems and how we want to apply technology to them, what we started to do is actually to think about the process and to start to try to map that drift. What we would generally do in a normal software development cycle is to create a process map of what people were doing. And this is just not distilling that process map into some kind of lowest common denominator, but actually maintaining that level of variance. It requires a lot of user research, both in interviews and observations. But once we get a sense of like where there is drift, then we can start to ask ourselves like, what's causing that drift? And like, what kind of technology can we bring to the table to resolve those problems and reduce or eliminate the need for drift? If drift is being caused by something actually blocking the process from moving forward, we can probably produce some sort of technical solution to unblock it. But if a drift is being caused by too much variation, then that's a place where we know we do not want to eliminate the human in the loop. We do not want to remove the human operator from being involved in the decision-making process there, because there's more variation than we can actually express effectively to a computer. And we also kind of want to think about it in terms of like, how are we distributing and changing where the thinking is? Like, where is the type 1 thinking? And what causes the operator to use type 2 thinking in this particular process? Going through this process sort of allows us to generate a new list of problems. So rather than thinking about like what is the existing process and how can we make it faster and better, we start rethinking the existing process, reinventing the old process by designing specifically the human-computer interaction. Our goal is to combine the strengths of computers with the strengths of humans, not to just assume that computers are better and like wholesale eliminate the humans. And one of the big questions that we kind of keep coming back to is like, what is the intent of this system? To sort of ignore the format of the system and just look at like, what is the system actually trying to accomplish and how well does it accomplish it? So in general, the goal of AI and machine learning should be to direct human thought to where it has the most value and not to eliminate it. And so that kind of like concludes basically what I wanted to convey to you guys, but I wanted to just say that like this is just the beginning of the work that we're doing in this space. We have been experimenting with a lot of these kind of concepts, and we have regular conversations about like how we think we're doing on our ethical positioning and how we can be better. So if you'd like to continue to follow this conversation, you can sort of follow my thoughts about this on Twitter. And I post a lot of updates around what processes I'm working on and how I'm thinking about them to my Medium, both of which are under my account name Belmar. And if you'd like to reach out to me, you can reach me at marianne@rebelliondefense.com. So thank you so much. And I really look forward to the conversations we're going to have in the chat.
Thank you very much, virtual Marianne. Now we have actual Marianne here. One of the first questions I saw was, how can we recognize when a system incorporates a human in an ethical way versus when humans remain in the loop, but effectively it's still disempowering them?
I love this question because it ties into what I'm starting to work on now. There's an absolutely amazing paper called The Ironies of Automation that was published, I think, in 1983. So what's really amazing about that particular paper for me is that if you read it with an SRE mindset, it will explain a lot of concepts that are very deeply familiar to us. And yet it was published in 1983. So like there was this whole learning that was going on in manufacturing in the 80s that software completely missed and then had to relearn in its entirety. But one of the things the author hits on in this paper that I think is really interesting is this concept of learning in systems and processes, and that a repetitive action, no matter how tedious, isn't necessarily useless, even when the operator like really, really dislikes doing it, because it builds experience and expertise that allows them to actually be the sanity check for the automation. And then if you automate those processes, does that learning go away? And do you actually create human operators that are less knowledgeable and less experienced and less capable of managing the machine? And so that's sort of like one of the things that I would think about if we're talking about, like, is the human in the loop actually empowered, or are they just like there to check a compliance box and like make everybody happy, but couldn't actually overrule the system in the first place? It's like, how are they learning and developing deep expertise with which to challenge the determinations of the automation in that? And if you can sort of figure out where the learning is in the process, and if you want to automate that step where there's a lot of development going on for the human expert, like where are they getting it after you've automated it? And so thinking about those things like that, I think are useful.
Yeah. And I'm kind of curious, do you think there's anything that the government space could learn from the private sector or vice versa, especially in terms of ethics?
We have so much to learn from each other. It's fascinating. I think from the government, learning from the private sector, the government often traps itself into unsafe, insecure situations because they are so intolerant of risk that they choose options, especially with technology, that are almost guaranteed to fail, almost guaranteed to be less secure than what they could have done, but are like more established. That legendary phrase, "No one ever gets fired for IBM," like IBM is not the source of it anymore, but it still lives on in government. There are definitely choices that you watch people make, and they know it's less secure than what they should be doing, but it's what everyone else has been doing. So there's like this security blanket and hiding behind it. So like that's something like we continue to try to bring things like resilience engineering, chaos engineering, if you prefer the term, into government, reliability, SLOs, trying to kind of indoctrinate them into that way of thinking, because it will ultimately lead to more stable and secure systems for them. On the other side, I think that people in government think really deeply about impact, and that's often missed because that's not the kind of brand that we have in our society about what government is, particularly the federal government. But people are like, it is public service to them, and they really do think very deeply about the impact of what they're doing. And so it's always weird for me going back to like more startup communities and listening to people talk about IPOs and like their vesting schedule and stuff like that, and then being like, yeah, is this really what we're spending our time on? Like, I don't want to judge anybody, but like I'm judging just a little bit, you know. It's kind of like, I think that there needs to be a balance, and that I think that perhaps both communities can learn to sort of balance that thing, that exchange between the very pragmatic kind of capitalist side of life and the public service side of life. I think we can both kind of
even ourselves out on that front.